let's take the question, this questions, and we will be working with the question 9 through 14 right now. I will add 15 as well. Okay, so could you please explain, Omar Hussein, what did you do in order to solve question 9?
I just added the exponents because they have the same base.
Right, so you here, because we remember that stage number 1, we have to check that left and right side has got a single expression, right? Single exponential expression. As you can see on the left here, it's not a single expression, it's 2 exponential expressions multiplied. So no, in this case, we cannot drop the base. Okay.
But I didn't say I dropped the base. I said I added.
Yeah, what you did was correct. I'm just explaining why this is important, because maybe some people will do 3m times negative m is equal to negative 2m, which is not the case, right? So I'm explaining that we have to apply exponent rules or laws in order to make it a single exponential expression, which is as Omar said, we keep the base and add the exponent. So you will get 3m minus m as the expression. Now it's a single expression on the left side. And I keep the one on the right side. Now, when they are single, each one is single expression, we can drop the base and write the equation. So 2m is equal to negative 2m, right? So next stage, Omar, tell me the rest of the solution.
We're going to subtract 2m on both sides. So add 2m on both sides. So it's 2m plus 2m equals 0. So
okay, 4m so it's 4m, which means that m is 0. Okay, so as I told you, this is the second stage. Now we will be adding extra step in solving the equation. It's either applying one of the exponent laws, which we know, or looking for the same base. So look, let's do this question 11. This one. Okay. Has Farida joined? 11. No. Okay, so here we see that on the left side we have 2 exponential expressions with the base 10. Everything is clear. But what about the right side? The right side does not have the same base. It's 1 over 10.
We're going to do 10 to the power of negative 1.
Thank you, Natalia. So we remember that our main goal is to have the same base. So we know that 1 over 10 is the same thing as 10 to the power of negative 1. Okay, so now we can rewrite the right side as 10 to the power of negative 1. What is going to be now on the left side, Nada?
10 to the power of negative 3x plus x.
Next solution line, Rami. Rami.
Yes. Is it going to be 10 to the power of negative 2x?
Yes, but you don't have to do it. You can, once you have single expression here and here, you can drop the base and just equate the powers. So ignore 10.
So negative 2x then?
Yes, negative 2x on the left, and on the right?
Negative 1.
Yeah. Now, what's the x value?
X equals 1 over 2.
Yeah. Okay. All right. Thank you. Now, next stage is where it's not obvious. Okay. So, for example, 14. Question 14. What do you think we're going to do? Ideas.
Do you first switch the value on the right So that it can be 216 to the power of -1.
But it's not going to be the same base. We're going to have to see what, 6 to the power of what gives 216, which is 3. So it's going to be 6 to the power -3.
Absolutely. So we are always checking the constant, which is here. In what way? We are looking for 6 inside it, so that 216, which power of 6 is it? So if it's trial and error on the calculator. So 6 to the power of 3 is 216. So at the first stage, I'm breaking it down into steps. I can just write it 1 over 6 to the power of 3, right? But since we know that we want to have the same base, this is not the same base. What you have to do here is just to make the exponent negative. So 6 to the power of -3 is the same thing as 1 over 6 to the power of 3. And on the left side, you already know what to do. You can just add up the exponents. So it's going to be -2x minus x. Right? So -3x is equal to -3, which means that x, -3, which means that x is 1. Okay? All right. So now, something more challenging than that, which is, for example, 18 and 20. So these questions, this is, yeah, I will copy these questions for us to do now. From 17, yeah, through 24. Okay. Okay. Let's take 18, question 18. So, in the question 18, we have 2 exponential expressions on the left and 1 on the right. Okay, so our target is to have the same base. So whenever you have several exponential expressions, then definitely you will go for the smallest base. Okay, so the smallest base here is 3. Right? So that means that I need to represent 81 as the power of 3 and 243 as the power of 3. So please tell me, what is 81? Which power of 3 is it? And what is 243? Which power of 3 is it?
For 81.
243 to the power of 5.
Right, and 81?
4.
Right. So right now I'm going to rewrite the left side of the equation with the powers, with the base 3, following very accurately the exponent rules as well. So what I mean is 3 to the power of 4, right? This number is raised to this power, right? So it's not times, it's not plus. It's becoming power over power, right? Because 81 is already a power of 3. So this is going to be the expression in the numerator. And the denominator, I use 3 to the power of 5 instead of 243. So according to power over power law, this exponent will be outside like this. Right. Nothing is changing on the right side, and it's not going to change. Now, guys, what do you think we're going to do at the next step? Okay, now we have the same base. But remember, the other thing to take into consideration is that I have to have single exponential expression on both sides. And this one is still not single. Any suggestions, please?
Distribute
Multiply the
the
exponent with what's outside, like 4 times 2n minus 2.
Okay, Miriam, the other person was talking. Could you repeat what you said? I don't hear. Okay, so Miriam suggests that we apply power over power law here, which means that if I have an exponent here and an exponent here, I just need to multiply them. So I will move here. Okay, so it's going to be 3 and then 4 bracket 2n minus 2.
Miss, it's 3n.
Like in the question.
3n. Okay,
Yeah.
thank you. 3n.
Plus 2. No.
3n. Plus 2. I don't know what happened. Okay, thank you. Plus 2. Okay, and then down we have 3 and then 5 times negative n. Okay, all of this is equal to 3 to the power of 4. Okay, so now we have option. We can either simplify the exponents or you can apply the division law right away, right? To have a single exponential expression. So if I want to apply the division law, how will the left side look like at the next step? Omar Hussein.
Miss, you're going to subtract, right?
Right, yeah. So tell me what to write.
So isn't it 4 times 3n plus 2 minus...
We still do not, we are not dropping the base until you have single expression on the left and on the right.
Oh, so you expand? Like,
So
4
3 is the base still.
Mhm.
3 and 3 base. So, but you only do the operations at the level of the exponent, right?
Oh, okay, I understand.
So 4, 3n plus 2, and then?
Minus 5n, I mean 5n, negative 5n.
No, why did you drop this minus? Minus here is because of the division law. That's why do not be in a hurry. Apply the division law properly and then think about the negative, positive later on.
Oh, okay.
Right?
Okay.
Because it's this minus this. This is according to the division law.
Okay.
Okay, once you got single powers on the left and on the right, this is the time to drop the base, right? And I will just rewrite the exponents. So 4, 3n plus 2 minus 5 times negative n is equal to 4. Okay, so now we got a very simple linear equation, okay, which we can just rearrange and then solve for the unknown n. So 12n plus 8 plus 5n is equal to 4. Now, in the linear equation, we collect like terms and the constants go to the other side. So it's 17. N is equal to negative 4, right? Finally, n is negative 4 over 17. And that's it. So this is the solution. Let me just make sure that it's correct. This is question 18. Question 18.
Yes, Miss, it's correct.
Negative 4 over 17. Okay. Okay, so one more example. Example which I wanted to solve right now is 22. Okay. So in the example 22, well, from the first glance, you can think that the base which we should be targeting is 9, but it's not the case. So could you please check what is the right base to use in this equation by trial and error? I want to give you some opportunity for creativity. So it's not the base of 9. What should be the base for this equation?
Is it 64?
64 is the base? What does 64 have to do with 9? We are doing 22, Noor. 22.
I was doing another one, sorry.
Yeah. Okay, again, I will repeat my question. So which base should we target for this equation?
Is it 3?
It's 3, absolutely. Why, Miriam? Why is it 3, not 9?
Because I tried doing 243. I tried like squaring 3 and trying different exponents. And
Okay.
3 to the power of 5 is 243.
Okay, so the first thing you should do is to check whether 9, so if 243 is a power of 9. So if you try to square or to raise to the power of 3 and 4, number 9, you will never get 243. So it means that you cannot represent 243 as a power of 9. So you have to look for something else, like a common ground between 243 and 9. And the common ground is going to be 3. So if 9 is the second power of 3, right? Then 243 is, Miriam, you said what? 3 to the power of? Miriam.
3 to the power of 5.
Right. So it means that the 3 is going to be the base for this equation. So what we need to do right now, we have to replace each number with the corresponding power of 3, right? So 243 is 3 to the power of 5. So you just replace it with 3 to the power of 5 and keep the other exponent, which is k plus 2. Times, now I have 9. So instead of 9, I'm going to put 3 squared and keep the other exponent, 2k minus 1. And finally, the other 9 on the right side is 3 squared. Now it's becoming much easier to deal with, right? So tell me, what is the next step in, remember, having a single exponential expression on both sides? What's the next step? Miriam.
Miss, you drop the base and then write it all as
Not yet. It's too early to drop the base. It's not single. You can drop the base when it's single. Miriam.
I expanded like the exponents, like 5k plus 10 instead of 5k plus 2.
Yeah. Okay. And then?
And then I did the same thing for the 2 times 2k minus 1, and then I added the exponents equal to 2.
Because it's a multiplication. So since it's a multiplication, I'm going to right away replace this, all of this, with a single base, and then add the exponents. Right? 2 times 2k minus 1 is equal to 3 squared. Okay? So once you have the single expressions on both sides, you can drop the base. So 5k plus 10 plus 4k minus 2 is equal to 2. So 9k is 8. On the other side is negative, so negative 6. Therefore, k is negative 6 over 9, which is negative 2 over 3. So this is the final answer.